Now let's get started with the content of week 2. So we're going to start this with elasticity, and now the one that I'm talking about is this file, sample question 2a, elasticity. Okay. I would suggest that you watch my recording of 2a series, okay, with reference to this Word document. All right, let's get to it. What is elasticity? Well, better that I share the screen this way. Well, the elasticity, it is defined as the responsiveness of one variable, which is usually the dependent variable, the consequential variable, okay, to changes in another variable, okay, which is usually the independent variable, or namely the causal variable, okay? And we use percentage changes to avoid differences in measurement. What does that mean? Well, possibly you would consider, hey, if you want to measure how one variable responds to another, possibly just look at the changes. In math, it's denoted as delta. This little triangle means change, pronounced as delta. But here, a lot of times, it's not that reasonable. It's not that accurate if we merely look at the level of change themselves. For instance, if we have, say, a population change in Cedar City by 1,000 people, that could be a significant change, considering that Cedar City has a population of 20,000 or 30,000. But if it is only a 1,000 population change in Salt Lake City, which is much bigger than Cedar City, it's the same level of change, same, absolute value of change. However, the magnitude of change itself differs. How can we better measure it? We use percentage change. We use like 1,000 over, say, 20,000. Okay. Let's switch to this. We use 1,000 over 20,000. Right? That is the percentage of population change. The change as a percentage of total, which is 1 over 20, roughly 5%. Right? And say if so this is Cedar. So say if Salt Lake City is 10 times bigger, it's still 1,000 people change, but here the total population is 200,000, right? And then it is 1 over 200, which is 0.5% change for Salt Lake City. So here I'm demonstrating to you, right? It could be the same level change. They are both 1,000 population change, but it can be two distinct effects to two different cities of different size of population to start with, right? So it's more reasonable, more accurate for us to measure those change with percentage changes. And then let's go to the formula of elasticity themselves. And here it is version 1 formula. Version 1 of the formula of elasticity. I call it the percentage version, or percentage change version. Okay, let's use quantity and price as an example. In that, this formula is written as percentage change in quantity over percentage change in price. Let's go back to its definition. It is the responsiveness of one variable to changes in another variable. So it is to measure how Q responds to change in P. And delta, which is this triangle, it means change. Okay, so this is the version 1, which is percentage change. And here you should figure out, in this, P is the cause, or namely independent variable, and Q is the consequence, and also the dependent variable. Right? If we were to have, say, a PQ function, then it should be that Q expressed as a certain form of P. We're using P to express Q, namely Q is your Y and P is your X. Right? It is because P changes first, then Q changes consequently. Okay, so this is how the story is told. Always in the numerator, you will have the consequence. And in the denominator, you will have the cause. And here, this percentage change quotient is to say how many percent will your quantity change per each percent of change in price. We have to unitarize it, right? We were to standardize it for better, for future convenience in comparison. Okay, so this is the percentage change. This is the very original definition. Okay, then let's look at the magnitude of percentage change. Okay, so we use the absolute value to tell if this, say in this case, if this very agent in question, right, is elastic or inelastic. If E is greater than 1, it is elastic. And if the absolute value of E is smaller than 1, it is inelastic. And if somewhere in the middle, E equal to 1, we call it unitary elastic. All right. And we're going to get to unitary elastic later. It is a very important feature for us to help us to find the revenue maximization conditions. But let's look at these two first, okay, which are more commonly seen cases. Okay, so elasticity being the absolute value of the elasticity being greater than 1, that means the absolute value of this quotient being greater than 1, right? If this quotient is greater than 1, then it means that the denominator, right, should be smaller than the numerator. The bottom should be smaller than the top. That is what this E's absolute value being greater than 1 is telling you. So in that, it actually means the quantity changes more than your price, right? The top is higher than the bottom. Quantity changes more than the price. And here we have the opposite. If it is inelastic, namely the absolute value of this quotient is smaller than 1, that is to tell you Q changes less than P. Okay, those are basically what those elasticity can be categorized, okay, as a relation, as a reference to this percentage version of the elasticity expression, elasticity formula. Now, let's make a better sense of it. Okay, Q changes more than P Well, when this say here, if it is a demand elasticity and we are looking at a consumer, consumer is the agent that we are looking at. In that case, this consumer is elastic. What does that mean? That means if the price changes a little bit, if the price rises a little bit, the quantity will drop a lot, right? So this is the case where the consumer is sensitive to price. Okay? Or elasticity, if we put it in the daily language, a layman language, we will call it price sensitivity. Okay, so that's one thing. And here in this, in the second case, when this consumer is inelastic, that is to say, the top is smaller than the bottom, right? It takes the price to increase a lot for my quantity to start to drop. Okay, so in that case, it is as if this consumer has a strong loyalty to this product. So inelasticity is also referred to as consumer loyalty if it is an elasticity of demand. Consumer loyalty or dependence, right? If this product is, say, your daily essential, like gas, right? Recently, we have seen the gas price being skyrocketing, right? Why are people so sensitive? Why are people so concerned about it? That is because we have a strong dependence on gas being one of our daily essentials, right? That means even if the price changes, say from $3 a gallon to $4 a gallon, you still have to use that for your daily commuting, right? You can't cut short your actual consumption by a lot in the response to this price increase, right? You're stuck there. It's either your loyalty to this product, right? I love Apple products. I know that Apple, even though that I know that Apple is kind of overpriced, right? I'm still gonna buy a product no matter what. I'm not gonna cut short my consumption by a lot. In that case, we are observing an inelastic consumer. Your mind is made, right? Or if you have a strong dependence in this product, you don't have any alternative to go to. Recently, we still have to heavily depend on fuel power car for daily commuting. Then even though the price increased by a lot, quantity will decrease by a very small extent, right? Smaller than the price increase. Then you also observe an inelastic consumers, right? So in the first case, if consumers are elastic, that means there can be a lot of alternatives they can go to, right? So that they are sensitive to the price, they're shopping around. If your product is priced high, I can switch to others. I'm gonna cut short my quantity demanded instantly, right? But here in this case, when the consumer is inelastic, then we don't have a lot of alternatives. Okay, it's either you self-restrict, right? Because you specifically like a certain product of certain brand, right? Even though the price is so high, you will not cut short your consumption by too much, right? Even though there are a lot of alternatives, even though there are a lot of computer brands, you choose to be loyal to a certain brand, right? So in that case, even though there are existence of other alternatives, they don't exist in your eyes, right? In that case, you're very inelastic. That's one thing. Or in the reality, we don't have alternatives to go to. Like gas example. You're you're objectively dependent to this product. right? In that case, you are inelastic. So basically, here I'm introducing to you the conceptual understanding of elasticity starting from the version 1 of the expression, which is the percentage change version. Okay, and here we have the econ understanding. So now let's go to question 1 on the sample question sheet. So here, let me write down the expression again, elasticity. It really doesn't matter if you use lowercase or uppercase as long as it makes sense to you. That's good. Okay, elasticity is percentage change in quantity over percentage change in price. Okay, so here in this question, what I would recommend is when you are reading this question, you just try to grab a piece of paper and convert the verbal illustration into notations. Okay, in the first one, the question is read this way. It's written this way. The elasticity of demand for peanut with respect to its price is minus 0.3. So here, E is minus 0.3. Okay. If we expect the price of peanut to decline by 15%, the percentage change in price is 15. But don't forget, you need to put a negative sign to tell, hey, we're looking at a declination in price. Okay, then what is the expected percentage change in the quantity demanded? So now we are asking for quantity demanded. So here, look at this. We know the elasticity, okay? We know the percentage change in price, which is here, and we are asking the percentage change in quantity, right? We know 2, and we need to work out to the last one. So that is actually doable. So here, you want to figure out percentage change in quantity. So you just multiply the bottom to the other side, or you can consider here for this formula, we'll multiply percentage change in price to both sides of the equation. So on the right-hand side, you have the two same thing, it's canceled out. On the left-hand side, it is E multiplied by percentage change of price. Okay, then we can plug everything in, right? E is minus 0.3. And here percentage change price is minus 15%. So the result is 2 minus, we have a positive, right? And 0.3 by 15 is 4.5. So the result is the quantity should increase by 4.5%. Okay? So now let's discuss a little bit about the sign of elasticity. Okay? So for demand elasticity, its sign is negative, usually. That tells you why is this negative, okay? The sign of the top differs from the sign of the bottom. Why is that? This is what we call law of demand. Law of the demand is the reason why the sign of the elasticity for demand is negative, okay? Because quantity and the price, they change in opposite directions, okay? And here, let's verify and see whether it makes sense or not. So here, it is demand that we are looking at. And if price decreased by 15%, price decreases, conceptually we know it's getting cheaper to you as a consumer, then you're willing to consume more, right? So your quantity consumed should increase as a result, which makes sense overall. Okay, so here the solution is written here, but you should also make sense of the sign of elasticity. And here it is the version 1 of the elasticity of formula, which is also named as the percentage version of elasticity.